Hello, we continue on with our work in compound interest, and we're going to have a look at this question here. After how long to the nearest year will an investment of €15,000 have doubled in value at an EAR of 10%? Well, the first thing I need to do is recognize what type of question I've got. I've got a compound interest type question. So I'm going to go to my log tables and I'm going to write down my compound interest type formula. And then I'm going to fill in all of these different bits and pieces, and I'll usually be able to solve the problem then. So in the question, I have a big block of English. I want to translate it into these letters so I can sub in and make some progress. So I'm told I invest €15,000. That means the present value of my investment is €15,000. What other pieces of information am I given? Well, I want to know when it will have doubled in value. So that means my final value is going to be twice my principal, twice my present value. And what else am I told? I'm told the EAR is 10%. Well, I know that if I'm given any kind of percentage in these questions, I'm pretty much talking about the interest rate. And the A here stands for annual. So our yearly interest rate, again, if they don't give you any specific information, the interest rate is going to be in years. AER and EAR both being interest rates in years, is 10%. Always put that into your calculator by dividing by 100. In the exam, they will give you things like 0.1% interest, and it's very important that we are in this very structured habit of dividing by 100 to get our decimal interest rate. Otherwise, under exam pressure, it's very easy to just write down the percentage rate if they give you something that's 0.2 or 0.1 and just think that that is your actual interest rate. So that is our setup, and then we are looking for T in years. T in years is equal to what? We're looking for T in years. So if they had asked us to the nearest month, say, we might have converted this yearly interest rate into a monthly interest rate and then been looking for the number of time periods in months. In this case, they just gave us interest rate in years and they asked us to the nearest year. So we don't need to do any conversions, but that is something that they could have thrown into this question, that if they asked us to the nearest month, it might have been easier to convert the interest rate to the equivalent monthly rate. And we know how to do that. Now that we've got all of our different bits and pieces, let's just sub in. So the final value that we're interested in is when we have doubled our money. So it's going to be 2 times 15,000. So we have 2 times 15,000. They could have also just given us a particular number, like 45,000 or something like that. But here they give us an extension of the question effectively by saying wherein we have doubled our value. And we have 15,000 for our principal on 1 plus I yearly is 0.1. And we're looking for T in years, which I'm just going to call T. So I don't have to write as much, but we know that that is what we're looking for. So we recognize immediately, now that we've subbed into our formula, that we've got a problem where we have the variable, the thing we want, in the exponent. So we're effectively doing exponential equations now, and the rules and methods we know for exponential equations still work here. Now what I'm going to do is isolate my exponential, which means divide by 15,000 on both sides. And that leaves me with 2 is equal to 1 plus 0.1, or sorry, I can just write that as 1.01, or sorry, 1.1 even. To the power of T. I now have my exponent by itself. So what am I going to do? I'm going to take the natural log of both sides. This is how we deal with our exponential type equations, because we can now use the log rule If we have a power inside the log, we can take it outside. So we have ln 2 is equal to t on ln of 1.1. Now I want to get this t by itself, so divide both sides by the natural log of 1.1. Remember, natural log of 1.1, even though it looks like a big complicated thing, is just a number. It's just a decimal. So we get t is equal to natural log of 2 all over ln of 1.1 is equal to approximately 7.27. This is all in years, but I was asked to the nearest year, so rounding that, t is going to be equal to approximately 7 years. So that is how we can approach these types of questions. If we're asked for the time in these type of compound interest questions, we're really just being asked an exponentials type question, and we know how to solve those. Another style of question we can be asked is if we have multiple different options or multiple different situations and we want to know how to compare them. What we're going to do is find the present value of all of our different options. And that means that we'll be comparing like with like. Just like if we wanted to compare fractions, we would be getting the same denominator for our fractions. Here we want to get the same, we want to be comparing different prices or different prizes in this case, by looking at them at the same point in time. What is the value of these different payments at the same point in time? And the way that we do that is find the present value of all of our different options. So a prize draw offers two options. A, we get €5,000 right now in the present. Or B, we get €5,500 a year from now at a discount rate of 12%. A discount rate of 12%, again, if they give you a percentage, it means the interest rate. And if they don't give you any further context, it means it's yearly interest rate. Which option should we choose? Now, there's a bit of a trap here. If we think about this as an English question, you might want to make an argument that it's better to have money in the hand now. What they mean by what is the best option is what gives you the most money. What outcome is going to give you the largest amount of money, and to compare those things we need to get the present value of both situations. So that's what they mean by which one should you choose or which one is the best value. It means we need to compare the present values of both of these things based on this discount rate. So let's find the present value of both of these situations. Now for option A, so I'm actually going to, before we go into it, I'm going to write down that point because this is how we deal with these questions. Find the present value of all of our options. I'll write that down. Now, so that's it written out for our notes. Now option A is fairly straightforward because it's effectively already a present value. Present value is just equal to €5,000. No problem. The second one requires us to do a little bit more thinking, just a little bit. And I'm going to use a diagram, not necessarily because you would really need it to figure this out, but because it's reinforcing something that will be important later on. So you don't feel that this is necessary right now. I agree with you, but it's training us for later on. So what we've got with situation B is we've got €5,500 a year from now, and we want to know what that is going to be when we bring it to the present value. So this diagram again is going to be very important later on, so I want to reinforce it with you now. This is how we can draw out the situation that we are describing in this question. We want to take €5,500 and bring it to the present value, to year 0 or time period 0. So let's write out our information. We recognize this as a present value type of problem, or compound interest type of problem. So f is equal to p on 1 plus I to the power of t. What are my different bits and pieces for this? Well, my final value is what I've got, got that 5,500 euro is my final value. Pardon. My time is 1 year. And my yearly interest rate is going to be my discount rate. Is going to be 12%, which is 12 over 100, is 0.12. Always divide by the 100 on your calculator. It's extremely important for your exam success. And is there anything else? We're looking for the present value. So that's my formula I get from my log tables. Always go to the log tables to find it. There is a rearranged version of this where P is equal to F all over, or 1 plus T. There's no problem with writing that down, but this is the formula and they've just rearranged some of the letters. There is no difference. But if you want to write down the present value version of it from the log tables, there is no issue with that. So subbing in, we have 5,500 euro is equal to what we are looking for, the present value, on 1 plus 0.12 to the power of 1. Rearranging, as they have in the log tables, 1.12, and we can put into the power of 1 just so it looks more similar to more complicated situations. And we will get 5,500 all over 1.12, which gives us 4910.71 euro. So that's the present value of our 5,500 euro, taking the discount rate of 12%. Obviously, that's a fairly extreme discount rate, but it's what we're given in the question, so that's what we use. And we can make reference to the fact that if we have our discount rate of 12% in our answer. So based on our calculations, we would take option A, as 5,000 euro is greater than 4,910.71 at a discount rate of 12%. So we have said which answer we would go with. We have given a numerical reason why, and we've stated effectively our assumption, this assumption of the discount rate of 12%. So that guarantees that the examiner knows that we know what we're talking about.